Hi all, this is Mr. Yeager, and we are continuing our stoichiometry calculations. So again, this presentation was made by another excellent chemistry teacher in my team, and we're using it, and we're going to just expand the calculations one more step, basically. It's just going to depend on which side that step occurs. So last video, we learned about the mole ratio and how to convert between the mole of one compound to the moles of a second compound. And we use the mole ratio, which is developed out of the chemical equation, a balanced chemical equation. All right? All we're doing now is we're going to go and expand this one step out. We're going to be looking at it initially from here, where we're going to go from moles of one compound to mass of a second compound. So we're going to start with moles of one compound and go, I want to know how much mass is produced of this other compound. Well, what we're doing is we're adding one extra step. If I start with moles of one compound, the only way for me to change from compound 1 to compound 2 is through the mole ratio. So I have to go moles to moles first. And then the last step is one we learned last unit. To go from mole to mass, we use molar mass. Okay? So that's not new, okay? We cannot see that as new, and if we do see that as new, we haven't done a good job the first time around, okay? You haven't done a good job the first time around. You need to be going, I remember how to do this. This is not new. The only new step is this one in the middle, where we're balancing the chemical reaction and then pulling those numbers out. That's the only thing that's legitimately new, okay? So let's jump straight into the problems, okay? What mass in grams of glucose, again, some of these are tough because they're not giving you, I'm not expecting you to know what glucose is. C6H12O6. It's produced when 3 moles of water reacts with carbon dioxide. Okay? All right, so you can see here, I'm starting with moles of water. Oh, moles of water. I am starting with that. I mean, I'll write that down. That's fine. Let's write that on down. 3 moles of H2O. Okay? And I'm trying to go to grams of C6H12O6. Okay? I need to balance first. I have 1 carbon, 6 carbons. I need to put a 6 there. I'm going to skip O's for now because, again, there's multiple areas with O's. So carbon is good. Let's go to hydrogen. I have 2 hydrogens. I have 12. I need to multiply this by 6. I now have 12 hydrogens. All right, let's now finally do the oxygens. From the CO2, I have 12. From the water, I have 6 for a total of 18 oxygens. I have 6 from the glucose. I don't want to mess with the glucose, so let's not do that, because if I put a number in that, it messes up carbon and hydrogen, and they're good. But I can mess with the oxygen right here. I need 12 more, so what times 2 is 12? 6. So there is my balanced chemical reaction. Okay? 6 CO2 plus 6 H2O produces 1 C6H12O6 plus 6 O2. All right. I'm in moles of H2O, but I want grams of a different compound. The only way to change one compound into another is through the mole. I'm already in moles, so I'm going to come from moles of water to moles of glucose. This is my new step from the last video, mole to mole. Where do I find the numbers in front of it when it's mole and mole? I look up at the chemical reaction. I look at the coefficients. The coefficient in front of C6H12O6 is 1 because nothing is there. H2O has a 6 in front of it. So there's my mole ratio. Technically, if I stop right there, I can calculate how many moles of glucose I get, but I'm not interested in that at the end, so I need to keep going. I'm now in moles, so I'm coming from moles of C6H12O6, and I'm going to grams. I can always go from moles to anything else, like we learned last unit. Grams of C6H12O6. When moles is with any other unit, I put 1. This is not 1 because this is 1. That has nothing to do with it. When moles is with another unit that's not the mole, it's always 1. We're going to have some people that'll sit there and plug in, if it was carbon dioxide, they'd put 6 there. That's wrong, wrong, wrong. When I'm with moles in another unit, it's 1. Then I need to find the molar mass of glucose. Give me a second. That is 180.18. I now multiply everything across the top, and I'm going to divide by this 6 on the bottom. So 3 times 180.18 divided by 6, I get 90.09, which I need how many sig figs? 3. So this is coming out to 90.1 grams. That is my answer. Sorry that the answer is so small compared to everything else. But what did I do? I balanced my reaction. I know I'm starting in moles, so I need to go from mole to mole ratio, and then I just use molar mass to go from moles to grams. All right, try another one. All right, they're being nice and giving us the same equation, so that's fine. We know this is already 6616. This time, I'm starting with 3 moles of water, so 3.00 moles of H2O. And I want to go to grams of carbon dioxide, okay? So I'm going from moles of H2O to moles. I need to switch it to whatever else I want. In this case, I want CO2. The coefficient in front of CO2 is 6. The coefficient in front of H2O is 6. Some people sit there and go, should I reduce that? I wouldn't. I just leave it alone. Leave it alone, leave it alone, because I can clearly see that you grabbed it and you knew you're coming from that point. So I would not reduce it down. Okay? You can obviously cancel out if you're good with calculations in a moment, but don't worry about that. I'm now in moles of CO2, so that's what I'm coming from, going to grams of CO2. When grams and moles are together, I put 1, not 6. I put 1. When grams and moles are together, moles is 1, because this is the molar mass, which is the mass per 1 mole. The molar mass of CO2 is 44.01 grams per mole. Moles cancels out for the CO2. And then I do 3 technically times 6 times 44.1 divided by 6. Okay? I get 132.03, but I need only 3 sig figs, so this is 132 grams. All right? Process, process, process. What are you starting with? What are you coming from? What are you going to? What are you coming from? What are you going to? That is what you got to just keep in your head. One more, and then we're just basically going to do this kind of in reverse. It's not technically reverse, but we'll just call it that. All right. So I have a new compound here, a new reaction. First thing, let's balance. I have 1 Na, I have 1 Na. I have 3 Ns, I have 2 Ns. So I need to raise that to 6. So what times 3 is 6? 2. What times 2 is 6? 3. But now I have 2 NAs, so I need to put a 2 there. I'm balanced. All right, sodium azide is the Na3. So I'm starting with 0.500 moles of NaN3. And I'm trying to go to grams of nitrogen. So I'm going to change moles of Na3 to moles of N2. I look at the mole ratio, 3 to 2. I cancel out the moles. All right, now I'm in moles of N2. I'm going to go from moles of N2. Again, guys, I know my students sometimes struggle with this. If I do go back and get a problem where I said how many moles, I stop right here. I stop. I solve it and I'm done. But it's asking for mass, so that's why I'm going to continue going. So I'm in moles of N2, going to grams of N2. This would be 1 mole, because I'm with grams, and this is 28.02. So 0.5 times 3 times 28.02 divided by 2. I get 21.015. I need 3 sig figs. This is going to be 21.0 grams. And that's it. That's what we're going with. Okay? All right. Very much related to that is mass to mole. Okay? Mass to mole. All right? This is the same thing we just already talked about. This is stoichiometry. Okay? but we're now doing mass to mole. So what I'm looking at here is I'm going to be starting mass of one compound, calling it compound 1. I just call compound 1 whatever I'm starting with. And I want moles of the second compound. Well, I can't convert mass to mole in one step of a different compound. I need to the only way to change from moles of one compound to moles of another is through the mole. So I'm going to change the mass of compound 1 to moles of compound 1 using what? Molar mass. And then going from mole to mole using mole ratio. So it's just, all we're doing is we're starting with mass, having to convert that to moles, and then doing moles to moles instead of moles to moles and then mass. So we're kind of just reversing where we're starting at this. Okay? So here we go. We got a reaction with 3 products. So I have NaCl plus H2O. Let's see here. Okay. I have 1 Na, 2 Cls. So it looks like I'm going to need a 2 right there. And now I have 2 NAs, so I'm going to immediately take care of that, 2 NAs. So Na and Cl is good now. I have 2 H's. I have 2 plus 2. 2 H's here and 2 H's here. So that's a total of 4. So I need to multiply this by 2. And I have 2 O's, and look at that, 2 O's. It's crazy how that always works out. All right, so here we go. I'm starting with 250 grams of sodium chloride. We should know sodium chloride is NaCl. That's what I'm starting with. I want to figure out moles of chlorine, Cl2. So I'm ending with moles of Cl2. All right. Well, I can't change grams of NaCl into moles of anything else. The only thing I can change grams into is moles of the same compound. So I'm going from grams of NaCl to moles of NaCl. Since moles and grams are together, mole gets 1. NaCl, I should know that off. It's like 50, I know what it is. 58.44 grams. All right. Right there, that gives me moles. But I need to change now from moles of NaCl to moles of Cl2. Where do I look? The equation, the equation, the equation. Cl2 is 1, NaCl is 2. Solve. I multiply everything, that's all 1, so I'm going to be dividing by 58.4 and then also dividing by 2. Okay, so 250 divided by 58.44 divided by 2. Please don't multiply those at the bottom, unless you want to use parentheses, but that's going to be up to you to remember that. All right, I get a very long number, 2.138945927. 250 is only 2 sig figs because that 0 is not significant, so this is just 2.1 moles. All right, that's that. Next one. Ooh, much easier reaction. 1 Na, 1 Na, 1 Cl, 2 Cl, so 2 and 2 NAs. All right, how much sodium chloride in moles must be used for 88.6 grams of chlorine? So I'm starting with 88.6 grams of chlorine. And I'm trying to go to moles of NaCl. All right, I need to change grams to moles right away. Get out of grams, go to moles of that compound. All right, how many moles? 1. Not because that's the coefficient, because it's always 1 when it's just something else. And then this would be 70.9. Okay, 70.9. I don't know why I'm doing this up there. Yep, 70.9. Okay. All right, I'm in moles of coming from moles of Cl2, going to moles of NaCl. I look at the chemical reaction. 2 is in front of NaCl, 1 in front of Cl2. I do 88.6 times 2, divide by 70.9. 3 sig figs. This is 2.4992, so that's actually going to round to 2.50 moles. Last one for this video. One more situation. I don't want that one anymore. Let's try it. Okay, let's try this guy. All right, HCl. I have 1 H, I have 2 H's. I need a 2. I have 2 Cl's, 2 Cl's, 1 Zn, 1 Zn. I'm all done. Okay, I'm starting with 50 grams of zinc. And I'm trying to convert it to moles of hydrochloric acid, HCl. All right, I'm changing grams of zinc to moles, coming from grams, going to moles of zinc. 1 mole. Zinc has a molar mass of, I don't know that one off the top of my head, 65.39. 65.39. Grams is gone. I now go from moles of zinc to moles of HCl. Zinc is 1, HCl is 2, and I solve. So 50 times 2 divided by 65.39. I need 36 figs. This is going to be 1.53 moles. All right. That's what you're leading up to. So what we have covered so far is basically like the two sides of our big equation, all right, of our big setup, okay? We've gone mass of compound 1 to moles of compound 1 to moles of compound 2 at the end there. All right. We also showed starting at moles of compound 1, going to moles of compound 2, and then mass of compound 2. The big thing, guys, I cannot emphasize enough, is the only way to convert between compounds is with the mole ratio going mole to mole. So if anything fails, turn that other unit into moles, and then you'll be able to go from there. Our last step that we're going to see in the next video is we're going to go from mass of one compound to mass of compound 2. And you can see that's going to be 1, 2, 3 steps. 1 molar mass, a mole ratio, and then a second molar mass. So that is our largest of all the problems, but that's how we can do it. All right, that is it. Thank you very much.